Okay, so today I'm going to go over hyperbolic functions. Hyperbolic functions are basically, you know how sine, cosine, and tangent are circular, and we think about them in terms of the unit circle. Well, hyperbolic functions, we can think about them in terms of a hyperbola and what's generated from there. Very similar to how we draw our right triangles on a circle. We would work with it similarly with a hyperbola. We're not going to go too deep into this. This will be something I think you may explore a little bit more in Calc 3. And then if you go much further in math, you might see it on occasion in some higher levels of differential equations. So hyperbolic functions are special types of exponential functions that can arise in mathematics and physics. Okay, so we're going to define hyperbolic sine as sine h of x. Oftentimes it's called sinh. So let me see here. So right here, this is what sinh of x is. It's e to the x minus e to the negative x over 2. We're going to define hyperbolic cosine as e to the x plus e to the negative x over 2. That'll be cosh. And that's not multiplying by h. That's literally the notation. COSH is cosh for hyperbolic cosine. Okay. They behave very, very similar. Nearly identical to sine, cosine, and tangent, and secant, cosecant, and cotan, and the relationships are very similar. So this is what they would look like if you graphed them on a calculator. That's what y equals sinh of x would be, and y equals cosh of x would be. Oftentimes, hyperbolic cosine is the one people think of most because whenever you walk outside and you see telephone poles and the wires that's between them, that little dip, that is hyperbolic cosine. That's cosh. So sometimes they'll have like application problems involving that. Like I said, we're not going to go too heavy into this. I want you to be able to do the problems when asked. I want you to be able to, if you run into a hyperbolic cosine or a hyperbolic sine, you know exactly what it is. But really, the main thing we're going to do is kind of learn what they are, how they're defined, and then that very close relationship they have. A lot of times I think they say it's analogous with trig functions, okay? So the big thing is that sinh and cosh kind of define everything, just like sine and cosine define everything for trig. It seems like sinh and cosh do similar for hyperbolics, okay? So basically, if you want to know what tangent is, hyperbolic tangent, you just take sinh and divide it by cosh, and you would get hyperbolic tangent. Cosecant or hyperbolic cosecant of x is 1 over sinh of x, hyperbolic secant, so on and so on, okay? So the derivatives actually match what you think they would, just like with sine, cosine, and tangent. The derivative of sinh is cosh, okay? The derivative of cosh is sinh. Just like with sine and cosine, the derivative of sine of x is equal to cosine of x, and the derivative of cosine of x is equal to negative sine. So there is a little difference on where the negative signs go. For sinh, cosh, and tangent, there are no negatives in front for their derivatives. And then for all of the reciprocals, cosecant h, secant h, and hyperbolic cotangent, they all have negatives in front of them. So that's actually the one little weird difference is where the negatives go. But again, if you were thinking of tangent, if you were thinking of just plain old tangent of x, the derivative of tangent of x would be secant squared of x. Well, the derivative of tangent or hyperbolic tangent of x is hyperbolic secant squared of x. Okay, so it kind of relates. So if you're good at sine, cosine, and tangent derivatives, then you'll be good at hyperbolic derivatives. It's really nothing to be too scared about. So I just wanted to do a little practice with you guys. Nothing major. Like I said, this isn't going to be a huge section. This is just like background of stuff that'll come up later. A random problem here or there might have this derivative or this integral, so on and so on. I'm going to probably focus more on derivatives on the homework and if anything comes up on the exam. But integrals will do, but we're not going to go too crazy into it. So I asked you to evaluate hyperbolic tangent of ln of 2, that means I need to figure out what the heck hyperbolic tangent of x would look like. So what I'm going to first do is I'm going to do hyperbolic tangent h of x, and that's going to be, now remember, tangent is sinh of x over cosh of x. So that's really going to be e to the x minus e to the negative x over 2 divided by, well, I can just write it like this. divided by e to the x plus e to the negative x all over 2. So now we know that the 2's are going to cancel, and we're going to be left with e to the x minus e to the negative x over e to the x plus e to the negative x. Okay, so we're kind of to that point. Let me just make sure I don't make any silly mistakes in here. So we have e to the x minus e to the negative x and e to the x plus e to the negative x, right? So now I can do tan hyperbolic of ln of 2, and that would be e to the ln of 2 minus e to the negative ln of 2 all over e to the ln of 2 plus e to the negative ln of 2. And let's see. This is going to become, going to have to do some quick cleanup here. E to the ln of 2 will just become 2. This will become, so I could put the negative, no, yeah, you got to put the negative back up top. So this is actually, let me do a little scratch work for you. This is actually ln of 2 to the negative 1, which is actually 1/2, right? So this is ln of 1/2. So this will actually be 2 minus 1/2 all over 2 and then plus 1/2. So when everything is said and done, this will end up being 3 over 2 over 5 over 2, and that would end up being 3 over 5. And that would be our answer. So that's how we could evaluate hyperbolic tangent. Not super easy, quite a bit of work. If we wanted to, what we should have done from the beginning is maybe when we had defined tangent h, or hyperbolic tangent of x, we should have written it as this guy right here. So we knew that sinh over cosh would end up becoming that. So that's like almost like a formula you can memorize if you want. Let's simplify cosh squared t minus sinh squared of t. So what I'm going to do first is I'm going to rewrite what cosh is, stands for. So cosh is actually e to the t plus e to the negative t over 2 squared minus e to the t minus e to the negative t all over 2 squared. So far, so good. Now this, if we FOIL this out, this will become e to the 2t. Let me see here. And then the backside will become plus e to the negative 2t. And then when we do e to the t times e to the t, I believe, I'm going to have to do some scratch work real quick, you guys. I'm trying to do it in my head, but it's not going to work. So I'm going to do e to the t plus e to the negative t times e to the t plus e to the negative t. So this will become e to the 2t, because t plus t is 2t. And this will become e, oops, oh, that's why. Yeah. Okay, so this will become e to the 0 plus e to the 0. And this will become plus e to the negative 2t. So e to the 0 and e to the 0 will become 1 plus 1, which is 2. So this will become plus 2, all divided by 4. Now this will be minus, and then this should be very similar. This should be e to the 2t minus 2 e to the negative 2t, oops, plus e to the negative 2t. Let me clean that up. All over 4. So then when I clean this up, we got e to the 2t minus e to the 2t. So this guy should cancel with this guy. So we have everything over 4. Then we have e to the negative 2t minus e to the negative 2t. So those are gone. And then we have a minus and a minus 2. So that's plus 2. So we end up with 4. So this becomes 1. And that will be our answer. So not so bad, just a little bit of weirdness to it, something we're comfortable working with a lot. We haven't very often, but I just wanted to show you guys a few like plug and chug problems, and not really crazy. Do you think it's a coincidence that it equals 1? Doesn't this look an awful lot like the Pythagorean identity? But instead of being sine squared plus cosine squared equals 1, it's cosh squared minus sinh squared equals 1. So this is the Pythagorean relationship of I shouldn't say Pythagorean, but this is a similar relationship in hyperbolics, okay? Kind of their identity. Okay, so now I want you to differentiate h of x. So what we're and h prime of x is equal to, now I got to do the product rule just like before. So this will be 1 times hyperbolic sine of x squared plus x times the derivative of hyperbolic sine, which we know is cosh of x squared. But then I got to attach the chain, right? Because it has an inner function of x squared. So I got to do 2x right there. So we're going to end up with hyperbolic sine h of x squared plus 2x squared, right? Cosh x squared. Okay, so that should be our derivative. Let me just double check to make sure I didn't make any silly mistakes. Yeah, 2x squared, cosh x squared, and sinh x squared. Yep, sounds good. Let's do one more derivative over here. And again, like I said, guys, we're not going to go super in depth. I just want to expose you to this. If you go into more of a specialty field of mathematics, you'll probably encounter this more than I have. I probably dealt with hyperbolics maybe 10 times after this class, maybe I'm just not remembering, but I don't remember dealing with it a lot in upper division, high levels of math. But it could have just been my specialty. So f prime of x is equal to, now we have to do u prime over u. We're going to use our little technique for, also if you had another instructor, your instructor would have told you to do it this way, you know, or times u prime, but that's really u prime over u. So I just write it like that, okay? So let's see, the derivative of cosh is sinh, right? Sinh x, hyperbolic sine, and then rewrite it. That's u prime over u. But we know that sinh of x over cosh of x is actually just tanh of x. Okay, so not so bad. Oops, should be using blue. Okay, so it's not terrible. It's just, again, a little uncomfortable because this is kind of a new thing. But basically, think of trig. It behaves very similar to trig. So if you know how to work with trig and derivatives and integrals, you should know how to work with sinh and cosh and so on and so on. So now for this problem, I want you guys to integrate. I'm not going to go too crazy into integration. I just want you to see that it kind of works the same. I might give you a few problems like it. So we have cosh 2x times sinh squared 2x dx. So we have to decide what technique we're going to use. Looks like a pretty straightforward u sub. So I'm going to let u equal sinh of 2x. Now the reason that I'm using sinh of 2x and not just 2x is because if I just let u be 2x, then I would have cosh of u times sinh of u, or sinh squared of u. That doesn't really help me at all. So what I'm going to do is I'm going to say, well, I know that u is equal to sinh of 2x, then the derivative of that would be cosh of 2x. So I'm thinking ahead of the game a little bit. So this would be cosh 2x and then times 2. So then I know that I got to divide by my little 2 right here. So then we have the integral. Now cosh of 2x is worth du over 2, so pull the 1/2 out and put the du there. And then we know that sinh of 2x is worth u, so this becomes u squared because it's sinh squared of 2x. So now when I do this, I get 1/2 u cubed over 3 plus c, oops. So then this would become 1/6. Now we know that u is worth sinh of 2x, and now it's cubed, so I'm going to put a little 3 right there, plus c. Okay, and that would be how you could do an integral. Again, I'm not going to go too fancy on this in this class. Now, as it turns out, there is also inverse hyperbolics, and you might have to find derivatives and integrals. I'm not going to focus too much on that in this course since it's online. We already have enough to worry about right now. Even if it wasn't online, I probably wouldn't really go too crazy on it. maybe in one of the meetings, I'll go over a word problem or something like that with you. But I think that's all I want to cover from Hyperbolics, just to kind of give you guys on how to do some of them. You might be asked in the homework to prove an identity, so you just kind of substitute in the exponential functions that are defined by sinh and cosh, or that define sinh and cosh. So just give it a shot. Let me know how it works out in our next meeting, and I will see you then.